So right now you're going to use your exponents and you're going to use your trig functions, but it'll only be the basic ones. So you need to know your sine, cosine, tangent, right? Your secant and your cosecant. You need to know those derivatives, right? So that you can recognize that to go backwards. All right. So for this first one, I would rewrite it to begin with. So before I even start my antiderivative, I would rewrite it 12 over 5 x to the 1/5 minus 12 x to the negative 5. And I'm taking the antiderivative of both of those. Remember, I'm going to add 1. So typically when I do this, I write my coefficient first. I write my variable 1/5 plus 5/5 is 6/5. And then I'm going to divide. And when you divide by a fraction, just flip it, right? Minus. Then I'm going to do that 12 there. My new exponent, negative 5 plus 1 is negative 4. And then divide by negative 4. And then I will simplify it. These cancel, those cancel, so I get 2x to the 6/5. The negative 12 and the negative 4 reduce to a positive 3. And that x to the 4th is going to go on bottom. And then, of course, we need our plus c. And so plus c is my final answer here. Looks like that. For 7 and 8, really that's just memorization, right? Secant squared should be a familiar derivative. It is the derivative of tangent. So secant squared matches up with tangent. So I'm just going to say, well, the derivative of this piece right here, that is tangent. And then I just multiply by what was in front of it, negative 2. And then, of course, we don't forget that guy. And so those are pretty straightforward. There's no big things going on with derivatives of trig functions. You just need to know them. This says evaluate the integral for the particular solution. Given the initial condition. So the first thing I'm going to do is I am going to just take my antiderivative. So negative 20, my new exponent is going to be 4, and then divide by 4. Plus 6, my new exponent is going to be 2, and then divide by 2, and plus c. And of course you want to reduce it. So we have negative 20 divided by 4 is negative 5x to the 4th, plus 3x squared plus c. It gives me an initial condition of a 1. All right, initial condition of a 1, which means if I plug a 1 in, it should equal 2. All right, so I'm going to plug the 1 in. I am going to say negative 5, 1 to the 4th, plus 3, 1 squared, plus c equals 2. That is my initial condition. Simplify it. We get negative 5 plus 3 plus c equals 2. Negative 5 plus 3 is negative 2. Add over, c is 4. Once I know my c, I just rewrite this guy for a particular solution where c equals 4. So I'm going to say my final answer here is negative 5x to the 4th plus 3x squared plus 4. That is my particular solution here. We are going to approximate the area under the curve over the given intervals using 4 rectangles, okay? So n here equals 4, all right? So my width, remember my width is the subtraction between the two endpoints. 2 is my width divided by how many rectangles I have, divided by n. So my width here is going to be 1/2, okay? My height is going to be this width times I, so I get I over 2 when I plug it into my function. So I have to plug that into my function. So I'm going to say negative I over 2 squared all over 2 plus I over 2 plus 5. I over 2 squared is I squared over 4. Over 2 is I squared over 8. So all right, that is my height. All right. So in order to do this, I am going to say this is my summation then. And since I have my n, I'm not using my limit theory here. I'm using 4. So I'm going to say from 1 to 4 of my width times my height. So I'm going to take this guy. That's my height. My width was this. All right. Distribute him through. And then you're going to take the summation of each of these, right? Use your summation formulas here. So the summation formula for I squared, I'm going to go ahead and take out that negative 1/16 and do my summation formula for I squared. That's n plus 1, 2n plus 1 over 6, right? That's I squared. Plus, this is over 4, so I'm just going to put a 1/4 out here and do my summation for I. That's n plus 1 over 2. And then this is just going to be my constant times n, right? Now, if this were limit theory, I would say simplify him and do limit theory. But this is using 4. So if you want to, at this point, just plug in a 4, right? You don't have to like go through and simplify it. So I could say negative 1/16, plug in a 4 anywhere you have an n. 4, then 4 plus 1, that's 5. Then 2 times 4 plus 1, that's 9, all over 6. You see what I'm doing? I'm just plugging in my 4. Plus 1/4 times 4 times 5 over 2, plus 5 halves times 4. Lots of fractions. It's okay. Just simplify it. So I would like cross out the 4 and the 16 here. I would do the 6 with the 9, right? We're just basically simplifying. So I have 15/8 plus the 4s would cancel, 5 halves plus this would cancel, 10, right? Does everybody see what I'm doing? And then just get a common denominator. So 8 is obviously my common denominator. So I have 15/8. Common denominator here would be 20/8. Plus common denominator here would be 80/8. This guy is negative, by the way. So negative 15/8, positive 20/8, plus 80/8 is 85/8. If it wants it rounded, then you're just going to round it. It just depends on what it asks for. Walking through this, your width, you're just subtracting your two endpoints, 2 minus 0, divided by how many rectangles it wants, 4. 2 over 4. My width is 1/2. All right. My height is the width times I plugged into my function that it gave me. All right. So I just plugged it in everywhere there's an x. I over 2 squared. I over 2. I just plugged it in and simplified it. This is my simplified version. All right. If I want to find my area, I'm going to do my height times my width. So I just distributed my 1/2 through. And then I plugged in my formulas for my I squared and my I and my constant. So I replaced the I squared with this, replaced the I with that, and multiplied my constant by the n. At this point, if you know what your n is, plug it in and just solve it. Okay, plug it in and solve it. That's all I did from this point forward. I was just plugging it in and solving using order of operations, really. Basic order of operations. This is literally just using your summation formulas, okay? So when I'm using my summation formula, I'm literally, this one makes me put a K because I means square root of -1 to my program. So if I put an I there, it would be very confused. So it just does a K, but just think of that as your I, okay? That's what you're replacing. The reason you know that is because that's what's right here, okay? See, the variable they use here is the variable that you're gonna replace your summation for, okay? So I'm literally just gonna take this guy and replace that with the formula for I squared. So I'm gonna say 8, and what we just did was n plus 1, 2n plus 1 over 6. And then plus 10, and for a constant, you just say times n. Now for this one, it says simplify them. So it wants the simplified version, and then it wants you to plug in a 15, okay? So we do need to simplify this guy. I would reduce as much as you can reduce. Simplify this by just foiling and multiplying through. So 2n cubed plus 3n squared plus n is what all of those multiply to, all right? And then you're gonna put that 4 through. So I have 8n cubed plus 12n squared plus n over 3. And then we also have plus 10n. You're gonna need a common denominator there. The common denominator is 3. So that's 30n. So I have 8n squared plus 12. That's cubed and squared plus n plus 30n over 3. And I'm going to do it with fractions. 8 thirds n cubed plus 4 n squared plus 31. Oh, this should be a 4. There we go, 4 plus 34 over 3n. All right, that's my simplified version. All right, simplified version there. So this is part of the answer. That's part of it. And then it says what happens when n is 15. You're going to plug it in. So you're gonna say 8 thirds 15 cubed plus 4 15 squared plus 34 over 3 times 15. Okay? So 225 times 15, 5, 1,000, 125, I think, times 8. 8,800. All right, so for limit theory, you'll notice the last 3 sections just use your summation. That's all it does, right? It wants you to evaluate the limit. And I'm not even asking for area under the curve, so I'm not even making you set it up. I'm just handing it to you and say use limit theory. So for these, you're going to just simplify them. You will say, okay, this is a constant. So I'm going to multiply 15 over n times n. All right. 15 over n is a constant. 18 over n squared is a constant. And then I'm going to replace that k with my summation formula, which is n plus 1 over 2, right? So this one is really simple. Very simple. They canceled out all your n's. They were very nice. Those cancel to give you 15. This guy becomes n squared plus n. So one of your n's there can cancel. But you don't really need to. Just distribute that 18 through, okay? So we have 18n squared plus 18n over 2n squared. And we are doing a limit theory here. Okay. I have the limit of a constant. What is the limit of any constant? It's just the constant, right? And then my degrees are the same. So what do I do as it approaches infinity? 18 over 2 is 9. My answer is 24.